it's things with integers for exponents, and it can go as high or as low as you want to go. It has to be positive. We're not dealing with negative exponents here. We're not dealing with fractional exponents. Okay, they're just positive numbers. We will be graphing all of these. So if you remember last year, basically just dealt with quadratics, right, up to x squared. Because all of these are functions, we can graph anything of any degree in this course. That's what I'm going to do. Yes?
Are those n's like subscript?
Subscript. A to the subscript n. So it'd be like, in this case, a to the 5, x5, plus a to the 4, x to the 4, plus dot, 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 dot.
Is there any difference between subscript and superscript?
Just that superscript's above and subscript's below, that's all. All right. Lucas, are you almost ready? Yeah. No, this is a lot of decimals, right? This is a lot of notes today. Give me a few minutes to get my notes out, and then I'll pick up. Sound fair? Yeah. Here we go. We're going to say a power function of a polynomial. Is of the form y equals a x to the n, where n is an integer. Okay, if there's questions we can't see, I'm sorry if you can't see. If you don't understand something about the notes, I hear a lot of whispering. So I want to make sure that everyone sort of gets what I'm saying there. All I'm saying is that we're dealing with power, with integer exponents that are whole numbers. That's all I'm saying. Okay, does that make sense? If I were good? Yeah. Okay. I'm not just picking on you because your hair is amazing.
Is that a one or a comma?
This is a comma, sorry, this is my hair's a comma. Okay. And behavior is a big deal in this course. What this happens,
What's that?
our function I'm saying is it's the leading coefficient, so number something to the
I
end.
thought it was like something weird.
No, no. And behavior is what happens to the graph. As it approaches infinity. And what we say is x approaches infinity, or negative infinity. I'll get out of the way here, stuff like one right. Okay.
The I means infinity.
Sorry?
The I means.
Yeah, it's like a sideways 8 is infinity. It's a sideways 8 is infinity.
Then what's the I?
No, sorry, this one here, sideways. This means infinity here, I'm saying. Okay. This just means integer, like a whole number. Okay, are we ready? I'll give you, I'm going to pause for a sec, take a deep breath, and this is the key to today's lesson is coming up. So if you're fading out of today's class and wishing that there was coffee, this is the time to fade in, because this is the really important key to what you're doing. Is everyone else warm in this class other than me?
I called you a lot more for this option.
Please don't laugh. No. Is that a dead cool?
I heard something dying on this with the sequel.
Oh, really?
It's, so the arrow means the text goes to
Yes. Yeah. Okay, if the graph is x, x cubed, x to the 5th, x to the 23rd, as long as the exponent is odd, the end behavior will look like this. Okay, so as you go from left to right, it's going to go from the, what is that, third quadrant to the first. That's how the end behavior is going to go. Now, different stuff will happen in the middle of it. Okay, and we'll deal with that in the next few days. But anything that is an odd function will look like that. If there's one thing you commit to memory from today's class, it's going to be that and my next example for even functions. Yes?
Does that say
As x, yes. As x approaches infinity, y goes to infinity. Then as x goes to negative infinity, y goes to negative infinity. Yeah. And I'm sorry, the way my lessons go is I write a little note at the beginning, then I do a million examples after that. Okay? So Lucas, you're lucky here. You guys are not very good. Okay, can anyone guess what's going to happen for even functions? Nobody can because you don't know yet, so let's need to do this. Not quite. Not quite, okay? Now, just think. The only even function you know right now is x squared. What is x? What's the end behavior of x squared? Yeah, it's a problem like this, right? Okay? X fourth is going to look like this, but the only difference is it goes like this. X to the 6th is going to look like this. X to the 8th is going to look like this. But still the same thing is going to happen on the end, right? So every even function as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to infinity. Okay, I'm going to use some examples of decimals in a sec, but I want to make sure that the basic ideas are okay. So if it's an odd function, it's going to look something like this. Okay, if it's an even function, it's going to look something like this. Okay? Right, that was an accident, not angry. Okay, I'm going to do some examples with decimals in a second. You guys can just watch and learn. Okay, but does the main idea make sense? If it's going to be odd, it's going to look like y equals x. If it's going to be even, it's going to look like x squared. Does somebody want to guess if this is y equals x? What do you think a negative odd function would be? Opposites. It's going to be like this. You think of negative x looks like this. So negative x cubed would look like this. Negative x to the 5th would look like this. It would go like that. Okay. If this is x to the 4th, what's negative x to the 4th going to look like? It's going to be downward. They're just going to flip. Okay, we're going to see that in our graphs here in a minute here. Okay, but that's sort of the main thing that we want to talk about today.
That's why always goes to positive.
Yes, for both.
Oh.
Right, because that's mean like as you're going up, it's going up to infinity. Okay. Jordan, how you feeling? Good. And you have a coffee in front of you, so you're wide awake. I'm glad you're there. Okay, I'm going to sit if you don't mind. And you guys don't need to copy this down. I want to get this over here, if you don't mind. If you have a phone with you and you have Desmos on there, you may take it out, because I'm going to Desmos right now.
You know, I realized last night that Desmos made question 8, well, no, with Desmos, question 8 took like maybe a third of the time more than the other ones.
Yes.
Yes.
Okay, yes.
Oh, there's just a question on the hill.
Oh, sorry. Oh, I'm sorry. I didn't realize you weren't done. Sorry. Go ahead. Okay, hold on. I can't hear. Sorry about that.
The second y here.
No, because if we take a look here, as the graph goes over this way, the y value is going to keep going up. You know what I mean? So if we're at like negative 50, we'd be up to net positive a lot. Okay, so if you have your phones out, you may actually use your phones for right now. I'm going to put a function into here, which is going to be y equals x cubed. Now, before I type in a 3, Lucas, According to your phone or the definition of end behavior, what's this graph going to look like? From where to where? Like if you go over this way, where's it going to be? And if you go over this way, where's it going to be? So when I go over, you can look at your notes if you need to. If we're going over to positive infinity for this one, where's the y value going to go for an odd function? Well, it's good. Well, it's a graph on y equals x cubed is on the same shape as that graph. Y equals x. Just like playing y equals y equals x, okay? So it should look something like this to you guys here, okay? Y equals x cubed. Here it is for the first time. Wow, isn't that magnificent? There's, how do I make this? Wait a second here. Oh, shoot, isn't there settings here? Projector mode, there we go. Okay, y equals x cubed, very cool. I'm gonna, now this is the neat thing about this. The only, you might want to write this down in your notes. The only thing that matters is the leading coefficient, or the leading term. Okay, if I say minus 5x squared, okay, the graph still is the same end behavior, okay? As I go to negative infinity, it's still going to look, this is what y equals x looks like, right? Right? And if you take a look, as I'm going over this way, the graph is still going up to positive infinity. As I go over this way, the graph is still going down to negative infinity. All that matters is this one. This other stuff is just used to make the graph, you know, have more humps and stuff like that, okay? But as far as the end behavior, the only thing that matters is the leading coefficient and the leading term. Does that make sense, what I'm saying there? Okay. All right. Who's feeling good about their knowledge of end behavior and wants to take this one? Can somebody be brave for me? Oh, come on. Okay, I'm going to write an equation on the board, and then we're going to graph it. Whoops. The equation I'm going to graph right now is going to be y equals 2x4 minus x3 plus 5x squared. Okay, just to make sure we know what's going on here, okay? What's my leading term? 2x to 4. So this is the only thing that matters. Is this an even or an odd function? This is an even function. So this is a positive even function. It's positive because of the 2. What does an even function look like? X or x squared? Uh-oh, x squared, right? So I'm guessing that the graph should look like this. There'll be other stuff, weird stuff going on at the end, but on the end points, it's going to go up and it's going to go up. Does that make sense? So I got that, the logic? Okay. So let's try and make that graph and see what happens.
Oh, it won't load.
It won't load. I hope it loads.
Oh wait, no, never mind. I made a mistake. It's
2x.
2 is subscript.
Whoops. Whoa, what's going on here?
Oh, here it is.
2x to the 4th, whoops, minus x, whoops, cubed, plus 5x
It's a lot easier
squared.
with the buttons.
Let's go down here. Make it smaller, okay? Even though there's weird stuff going on there, if you take a look, as we're going over further this way, the end behavior is still going up, and the end behavior is still going down. This is very useful to you guys who need to graph this stuff by hand. Okay, you can instantly find out if the graph's looking good or not. It's like if you do a parabola. If you do a parabola looking like this, that's not a parabola, right? And that's all we're saying for today's lesson. We're trying to say what the end behavior of the graph should look like. Okay. All right. Now you can take your notes out. Never going back to notes. Oh, I don't like notes. No, I hate notes. Okay. Example 2. I think example 1 is a different one. Example 1 we have? Yeah. Try example 1. Do a rough sketch of the following. Okay, now when I say rough sketch, all I'm looking for here is end behavior. That's the main thing that I'm looking for. Okay? I'm going to pick on, sorry, Regan, I forgot your name there for a sec. All right? Now, 2x cubed, that's my leading term. Is this going to be a positive or negative function? Positive, right? So leading coefficient is going to be positive. So is this going to be an even or odd function? Okay? Now, what does an odd function look like? Does it look like y equals x, or does it look like y equals x squared? Y equals x. So if I had to graph this one, it'd look, so y equals x is going to look something like this, what this graph would look like. There's my very, very rough sketch. What this means is x going this way, and y equals x goes like this, if you're curious. Okay, that's what y equals x looks like. So you're going to go, again, as you go to the right, the values get bigger. As you go to the left, the values get smaller. That's what I'm just trying to get here. Is this sort of okay so far? I'm going to do another one. Next. You're right. Are you ready? Oh. Okay. Is this a positive or a negative function? What's the lead coefficient? Positive or negative? Is it going to be odd or even? Is it odd or even? For the powers, so even. This right here tells you that it's even, right? Okay, Madison, you're doing a great job so far. Is x to the fourth going to be like x or x squared for end behavior? Now, if you're looking at your notes, that's okay, but you just use your head here for a sec. X to the, just plain x, is that an odd or an even function? Yeah, because x to the 1, right? X squared is going to be an even function. So because this is even, it's going to be the same idea as that. Now, this is positive x squared. This is a negative function. So where's negative x squared going to be? Upside down. So this graph is going to look something like this. I'll put a little bump in there because I want to. Okay, but that's the idea. The point is here, as we're going to negative infinity on your x values, your y values are getting smaller. Okay, as you're doing positive infinity over here, you're getting smaller there. Is this making any sense to anybody?
It's the bumping nothing.
The bump is we don't know how we're going to find it. We will find it eventually.
Curiosity, why do we only look like at parabolas? Like if you do other things, so they're not like parabolas, but they make weird shapes.
Yes, that's what we're looking into in this course. The reason you, okay, I'm going to be nice and say this. The reason you start with parabolas is because your brains aren't fully mathematically developed at the beginning.
Well,
Okay, so if you're in grade 10, you just got to remember. In grade 9, you start with lines. Grade 10, you do curves. Grade 11, you do sine and stuff, right? Grade 12, moving on to everything. Okay. All right, I want you guys to try this one for me, and then I'm going to pick on Olivia as soon as I pause the video. Y equals negative 2x to the 5 plus 4x to the 4 plus 3x squared. So I want to know if this is going to be positive or negative, and even or odd function, then try and do the rough sketch, okay, of what the end behavior is. Don't give me that look. You can do this. If I haven't told you guys this yet,